have practices and stuff. So I'm going to record this. So I just want to let everyone know. I wanted to do, usually I only do this before, like, this is just a first little quiz, and usually I only do it before, like big assessments, but there were a bunch of people absent on Friday for sports, and it's kind of the first quiz we're having. So I just want to make sure we all feel good about this material. And yeah, so this is open to any questions you guys have, and I'll be on unless, questions stop. We can end early, but I'm planning on being on until about 9 o'clock. And I'm going to share my iPad when the questions start and I can go through stuff. So feel free, anyone, to jump in if you have a question. And people will join as they may. And people tend to pop in and out, which is totally fine. So anyone can start if anything. Some people just come on, as I said, it just to sometimes listen to other people's questions, but if anyone has a question, I can start there.
Could we maybe go over some of the questions where you have to set a restriction for?
You mean to find an inverse?
Yeah, for the inverses. Yeah.
Yeah. What about if I give you guys one? So I thought this might be a question. So maybe let's start with the warm up where I'm going to give you one and you have to find the inverse. It's one with the restriction. Okay. So I'm going to share. Let's hope this works. I tested it out before, and I'm going to ask you guys if you can see my iPad in just a minute. Um, all right.
I can see the blank thing with the
Awesome.
drawing board.
Okay, great. All right. So let me put one up and you guys can tell me. I'm going to give you guys a few minutes to think about it so that everyone has a chance to try it and then we'll go over it. So the directions here would be find the inverse. And again, I anticipated someone might have a question about this, so I quickly made one up. And this is a challenging one too. But if you can do this, I feel like you can do all the ones of this type. Okay, so why don't you take a few minutes to think, to try that. So find the inverse of that and notice there's a restriction on it. Oops, sorry, there should be a squared here. And while people do that, if anyone else has like little questions they want to ask me, feel free to jump in. And if anyone's just joining, we're just working on this problem for a few minutes and then we'll go over it and then I'll answer other questions. We'll give it about 2 or 3 more minutes and then I'll start walking through this. Do you guys need more time or do you want me to jump in? Give it about 30 more seconds, then we'll go over it. Okay, so first, does anyone know or can tell me why I actually needed to put a restriction on this? Why did I have to say for x between -1 and 2? Why was that important here?
Because there's a
Because
square.
Yeah, because anytime you see something squared, it means it wouldn't be 1 to 1, meaning more than one x value would go to the same y value, which is not problematic for being a function, but it is problematic for having an inverse. So I had to put a restriction on there for you to even be able to find an inverse. So yeah, so I did put this restriction on there. And so another question, how the restriction, the domain restriction, what will that be for the range? So God, I just told you. Sorry. Will that be for the inverse? The the domain restriction for the original function is going to be the range of the inverse. So that will be very important to keep in mind when you find your inverse. So I'm just going to make a note of that. I'm just going to say the range of my inverse should be -1 to 2. And so that has to be the case if I find the inverse correctly, because remember, for inverses, domain and range should completely flip. I know some of you switch x and y and solve for the new y when you find the inverse, which we'll all do kind of later down the road. But right now, I'm going to do the undoing method. So to do that, I'd start with x and I write down the steps I took to get this function. So subtract 2, then I squared, multiplied by -1, added 9. Then there was a lot of steps in this one, sorry. Then there was the square root. Then there was multiplying by -1 again, and then adding 3. And to find the inverse, an inverse undoes a function, so you're completely undoing this function. So again, starting off with x, I'm going to subtract 3 first, and then I'll divide by -1. So that gets me 3 minus x, and the opposite of square rooting is squaring. Then I'll subtract 9. And then when I divide by -1 here, I'm going to now rewrite it just to make it cleaner looking like this. So the sign of those two terms change or flip. All right, what did I do? Divide by, oh, okay, so here's the one to worry about. The opposite of squaring is square rooting, so it's either the positive square root or the negative square root. And based on the restriction, you have to decide which. And so what do we think? In order to have a range of -1 to 2 for this inverse, do I want the positive square root of this quantity or the negative?
Negative.
Yeah, we're going to want the negative, and then you can totally be sure when you do the final step, which is add 2, which if this had all been positive, meaning a positive square root, I'm going to put my function notation, which is important. Um, then there is no way you'd have negatives in the range. If everything was positive, like if this had been a positive, there's no way I would have ever gotten -1. So that's why it has to be the negative square root in this case. Oh, we're not done though. So any questions on that part so far? Like how I got that inverse. I'm not done though, but any questions on what I've gotten so far?
Will you repeat how you like can differentiate between like a positive square root and a negative square root?
Yeah, so it's all about looking at the restriction because the restriction in the domain of the original should correspond to the range of the inverse. So when I look at this restriction here, I realize, okay, I'm going to have some negatives in my range, and then I'm going to go up to 2. So and sometimes you might have to test both. Like say I had this, say I had done the positive square root. I want to eyeball if my range would have made sense. Again, this has to be the range. And I know coming out of a square root without even doing any sort of detailed work, I know coming out of a square root could never be negative. So something that's 0 or positive plus 2 will never get any negatives. So that would be an issue. Whereas this one, I will get negatives here, that if we look at this one here, and it turns out that it will be just -1 to 2. And if you did your range analysis, you would see that. So that's what you want to look at. You want to look at that restriction and make sure that matches the range of your inverse. Does that make sense?
Yeah, that makes sense. Thank you.
Yeah, so sometimes maybe try both and see which one is going to give you that range. Okay, why so going back to why I'm not done. Why am I not done? What's the issue with my inverse?
You need a domain for the inverse based on the
Yeah.
range of the original.
Yes, that's exactly right. This inverse function would not have an inverse, which would be the original function, because it has this squared in here. So whenever you see a squared, whether it's in the original function or in the inverse, that means there needs to be a restriction on that. So in order to find the domain restriction, it's going to be the range of the original function. So going back to this original function, I'm going to use a different color here. Let's find the range. So coming out of the square root, what's going to be the smallest coming out of this square root here?
0.
Zero.
Zero. Exactly. The smallest is going to be 0, but the biggest certainly isn't going to be infinity. What's the biggest coming out of that square root?
3.
3, right? Because you've got 9 minus something squared. So you're always subtracting from 9, and the smallest that you'll subtract to make that the biggest number will be 0. So the square root of 9 is 3. So then we'll do this. So negative applied to 0 and 3 would be -3 to 0, and then you add 3. So 0 to 3 is the range of the original. So you're going to use that. That's going to be your new restriction. So you're going to say for x between 0 and 3. And now it perfectly flips, meaning the domain and range of the original function is the domain and flips with the inverse function. So the range becomes the new domain, and the original domain becomes the range. So that's the most involved these gets, in my opinion, because you have to think about the original restriction when finding the inverse, and then the inverse needs to also have a restriction on it. Okay. What else you got for me?
Can we go over when there's like x in the bottom of the fraction and like the top, so we have to do like the k plus 1 thing?
Sure. Yeah, let's do one of those. You mean a domain range problem like that?
Yeah.
Yeah, great. Yeah, let's do one of those. Okay. So the directions are going to be, and like before, I'm going to give you a couple minutes to try it first. Maybe I'll add a new sheet just so it's cleaner here. Okay. So find the domain and range. Okay, so let me see. Let me think of a good one. A of x equals, let's do 3 minus 5 minus 2x over okay, try that one. So domain and range. I'll give it about 2 more minutes. Okay. How'd that go? Well, let's see how that went. Domain hopefully is more straightforward. I only have to worry about the denominator not being 0. So what would the domain here be? Everything except what number?
1/3.
1/3.
One of
Careful. Yeah, it should be 1/3, right? Because if I set this cannot be 0, then I get can't be 1/3. And you can always test it, right? Always plug it into test. Oh, does that, just to check for, careless errors, does that in fact make the denominator 0? And it does, so that's a problem. Okay, so when you do the K part, and first of all, you recognize that because we only use this when we have an X in the numerator and the denominator. So I'm going to look at this piece here, and I'm going to set it equal to some random number K. Whoops, not cross out K, just equal to K. Because I want to figure out, is there anything that cannot come out of this part of the function. In other words, is there an x value that will never have a y value? So let's see. So 9kx minus 3k. And so when I do that, the only way I can't solve this linear function is if the coefficients of x are the same. So in other words, I can't have -2 cannot equal 9k. So k, or coming out of this part of the function, can never be -2/9. So that means when I think about the outputs, I've got 3 minus, the fraction piece can be anything except -2/9. So -2/9 to infinity. And if I multiply everything by -1, that means this, everything but 2/9, and then just add 3 to that. So this means the range is everything but 29/9. Did people get that?
Yeah.
Great. Others okay? Questions?
Wait, why did it switch from
Why
like
is
negative to or like minus to plus?
yeah, that was my question.
Oh, so it's minus this whole piece. So it's 3 minus that whole range of values. So that with that minus, it means I multiplied every one of these by -1, which means, yeah, the two infinities flipped, which doesn't matter that much, but -2/9 times -1 is +2/9.
Also, how did the fraction reach infinity? Or
Oh, how would it get enormous, you mean?
yeah.
Yeah, so I know sometimes it feels like, how is that ever the case? Well, pick like a huge number to convince yourself. Like if I set this equal to something like, even say 100,000, granted that's not close to infinity, but something big, right? I'd get 5 minus 2x equals 900,000 minus 300,000. And so I could solve for x there, right? Oh, 900,000x, sorry. I could solve for x there, right? It just wouldn't be pretty. It's not going to be in a nice number, but there is an x value such that the y value would be 100,000. Are you convinced?
Yeah, thank you.
Yeah, okay. I know sometimes when you think about it, you're like, wait, how is it if you have a 2x over a 9x? But it will achieve these types of problems. And when we start graphing things like this, they're called rational functions. You'll see why it makes sense that it'll hit everything but that particular -2/9, at least the fraction piece. Are people clear now about how it became 29/9? About that -1 piece?
Yeah.
Yeah, so once I have the range of values, then I kind of apply the order of operations. So it's going to be multiplied by -1, which just means everything flips signs, and then I add 3 to that. All right, so I'm a little worried that people aren't, because you're a lot of domain and range, a lot of inverses, but there's another big topic that we covered that I'm worried people aren't paying attention to. So I'm going to give you another problem, okay? So see what you can do with this. All right, I'm going to say I just made this up, so hopefully this works here. Okay, so I'm going to say let f of x equal -3 over x squared plus 1. And then I'll do g of x is the square root of x minus 3. Okay, yeah. And then let's find f of g of x and its domain and range. So you're finding the composition and then the domain and range of the composition. So let's give this probably about good 5-6 minutes. If you're doing this correctly, it's a little bit more thought-provoking. So let's try this. Give it about 1 more minute here. Okay, so remember, and I encourage you, if you haven't already, to, look back at the section 1.5 where this was talked about, which is composition of functions. And not only do you want to know how to compose the functions, but also what's important in finding the domain and range. So let's do this. All right. So we're putting the g function into the f function, which means wherever there's an x in the f function, I'm putting the whole g function. So to remind myself of that, but more importantly, to find the correct domain, I will say, okay, f of g of x is the same thing as f of whatever g of x is, which is the square root of x minus 3. And at this point, I tell myself, because x has to go through that inner function first, I check to see if, does that mean the domain right away is restricted? And it is. So right away, I'm only putting in values greater than or equal to 3. So that's really important. Okay, so the domain of the inner function really matters because it has to go through that function first. And now let's put it into the f function. So -3, and I'm putting in the square root of x minus 3 into x squared. All right, so it looks like that. I'm going to simplify in a second, but I just want to show you we're putting that whole function in for x in the f function. And the square root and the square, they undo each other. So this is just equal to -3 over x minus 3 plus 1, or x minus 2. Now, so if I just look at this end result, what would be excluded from the domain, just looking at the end result?
2.
2. Yeah, so looking at the end result, so the domain of the inner function and the domain of the end result do matter. So I say x cannot be 2. But I noticed from my original domain, or rather the domain of the inner function, 2 isn't even included anyway. So I actually don't even have to worry about that 2. So my domain is just going to be 3 to infinity. However, say it had been x minus 4, and so that meant x couldn't be 4, I would have to exclude that value. It just so happens, and by the way, I should have made the problem like that, but oh well. I didn't do the answer before I made the problem, so it just worked out this way. But 2 can't even come into play here, so that's why it doesn't when I find the domain. Questions on that part so far?
But so if that like excluded 4, what did you say would happen? Or if
Okay,
that-
so say instead, like say my initial problem, let's do a little aside. Say my f function had instead been, what do I want to do? Let's say instead it had been this. Actually, yeah. So say instead I had negative, say this was my f of x, -3 over x squared minus 1. So when I put in the g function, we would have had this. -3 over the square root of x minus 3 squared minus 1, which would have meant that I'd have -3 over x minus 4, right? And so that would mean X couldn't be 4. So then when I went to do my domain, I would write it starts at 3 because of my inner function restriction, and I'm good until 4, and then 4 to infinity. So I'd have to exclude that value. The only reason this didn't happen with the initial function I made up is because 2 didn't happen to be in the interval from 3 to infinity. Does that make sense?
Yeah.
I'm not sure who asked that, but yeah. So it just so happened I picked a lousy example, I guess, maybe, or maybe not. So, but yeah, so 2 wasn't in 3 to infinity anyway, so it didn't matter. But if it had been, I'd have to exclude that. So the biggest takeaway from this part of it is when you're finding the domain of compositions, you have to look at the domain of the inner function and the domain of the end result. Both of them come into play when you're giving the domain of the composition.
So we don't have to get the domain of like the outer function by
No,
itself.
you do not, because that outer function gets changed by the inner function. Yeah, great question. So the domain of the outer function ends up not coming into play. So domain of inner function and end result. Okay, let's actually find the range of both. Like say we'll call this problem B. Let's first find the range of problem A. Okay, so keep in mind, like it would be a different range, this problem, if the domain wasn't what it was. Because the domain, I'm only putting values from 3 to infinity, that means the denominator is going to range from what to what?
One to infinity.
Yeah,
Zero.
1 to infinity. That's exactly right. If the highest I can put in for X is 3, then 3 minus 2 is going to be the lowest. And then I'm putting higher and higher values for X up to infinity, which is not attainable, but to huge. So yeah, this is how the denominator ranges, 1 to infinity. And let's do that analysis. So negative 3 over 1 is negative 3. And then negative 3 over huge, what can we say about that? Positive huge too.
Approaching 0.
Approaching 0, and it's going to be from the negative side. So this is my range. Negative 3 to 0. How's that? Let's do the other one. Actually, let me give you a chance. Try the other one. Try if instead f of x had been this part in B with the x squared minus 1. So this is the composition here. And this is the domain. See if you can find the range of this. A little trickier. Give it like 2 minutes to try. Give it about 30 seconds, then we'll go over it. Oops. There we go. Okay, let's do this. So again, you have to keep in mind in this case what the domain was, because x can't just be everything except 4. So how does the denominator range in this case? Just looking at the denominator. Because remember, there's a low point to what I can put in for x. So what is that low number that I can put in for x, the lowest?
-1.
Well, you're right with the output, but what's the lowest x value I can put?
It's 3, 3.
3. Yeah, so when I put in 3, that's the lowest I can put in. So that will get me an output, you're right, of -1. And then I can't put in 4, which would get me 0. So that, and we know in the denominator we can't divide by 0. But then I can put in enormous x values. So this would be the range of the denominator, -1, excluding 0 to infinity. And then we're just going to go through that systematic process. So -3 over -1 is just 3. But what's -3 over a negative that's getting super close to 0?
Infinity.
It's positive infinity, yeah, right? Because it's a negative over a negative, so it's going to be huge and positive, yeah. So I've got on the positive side, so this here is going to result in positives because you're going to have negatives over negatives. So on the positive side, I've got a low of 3 and a high of enormous. And how about on the negative side? -3 over a tiny positive.
-infinity.
Yep, -infinity. And then -3 over a huge positive is going to get really close to 0. So that's going to be your range of that problem. So yeah, the tricky part is really getting that down. Looking at your domain from the composition and figuring out what that means for the output of that denominator in this case. Questions about that? All right, I've had a request to do another type of domain and range, so let me throw this at you. And other people, if you have other questions, you can think of them and shout them out at any point or put them in the chat, but here we go. So let's try find domain and range. And I just made it up, so I'm going to do it at the same time you guys do it. So f of x equals, let's do 5 over 9 minus 3 minus x squared. So try that. So find the domain. I'm going to try it too. Find the domain and range of that. Okay, let's look at this um, and then I'm going to go do a couple things that people asked for in the chat. So, but let's look at this together. Okay, sorry, went to sleep there. Okay, so domain, once again, we're just looking at the denominator can't be 0. And what did you all get for what the denominator can't be then?
0 or
6 or 3.
6 is right. The other one would be instead of 3, what would it?
0.
It should
0,
be
0, 0.
0.
Yeah.
So it can't be 0 or 6. So negative infinity, 0, 0 to 6, 6 to infinity. That's how you exclude both those. Okay, so now for the range, we've got, what is the denominator range from? It's this part that's limiting.
0 to infinity.
So this part, you're right, is 0 to infinity. So if I've got 9 minus that, what does that mean about the denominator?
Negative infinity to 9.
Yep, that's exactly right. But because it's in the denominator, what do I have to also exclude?
0.
0, right. And you want to make sure to do that. Otherwise, your range is going to get messed up. So you definitely, if it's in the denominator, and if 0's in that interval, exclude it for sure. Okay, so then 5 over negative huge is going to get really close to 0. And 5 over a tiny negative, negative infinity. So there's really no limitation on the negative side. But on the positive side, I've got 5 over a tiny positive, which will be huge. But then the closest it's going to get to 0 is 5/9. So that was my domain and range of that one. Yeah, so remember to exclude 0. And always when you're finding the range, start with whatever contains the variable and see if that has a limitation on its range and go from there. Okay, so was a question on, and I'm going to try to recreate it as much as possible. There was a question on 1/6, number 6. And here's how this question went. This question gave you the fact that f is the inverse of g. So in other words, f is equal to g inverse. Okay, and you know g. And then the question was, without finding what the function is for f, how can we find f of 4? And what we could do was the fact that 4 represents, we'd have the g function. And what does the 4 represent in the g function if f is the inverse of g?
G of x.
It represents the output of g, right? Because the output of g, because f is its inverse, becomes the input of f. So this is the output of g. And then it will spit back the input of g. So that's what you're trying to find. You're trying to find the input of g that gives me that output of 4. So that's why in that problem, we could set 2x minus 3 over x plus 5 equal to 4, and then solve for x. Because the key there is domain and range flips. So any input of one is the output of the other. So that's why you can solve those if you don't even know the other function, because inputs and outputs flip. There was another question on doing a inverse. Wait, so Danny, did you have a question on 1,3D?
Yeah, for 1.3, I was wondering how you find the range of f of x. Because I looked at the answer key and I didn't get the same answer and I was confused.
All right, let me see if I can find that one. Oh, yeah. Okay, so this was kind of similar to what we just did. Let me see. So and correct me if this is not the right problem, but I think it's this one, -9 + 8. Was it
Yeah,
this
that's
one?
correct. Yeah.
Okay, so look again. Oh, yeah, it's similar yet different to what we just did. This here is what's changing, right? So this would have a range of 0 to infinity, which would make the denominator have a range just like the other one from -9 to infinity, but you want to exclude 0.
All right.
Are you with me, Danny, so far?
Yes.
Okay. Okay, so then going through this, 3 over -9 is -1/3. 3 over a tiny negative is going to be negative infinity. So that's the negative side. And then the positive side, 3 over a tiny positive is huge. And then 3 over huge is really close to 0. And then you'll add 8 to each piece. So just don't forget the 8 part. And that's not going to mean anything for negative infinity and infinity, but it does mean something for the other two. So 23/3 would be this one, and then 8 to infinity. Does that make sense?
Yeah. Thank you. I was kind of confused just on getting out of the bottom part. For the
Okay,
denominator.
gotcha. All right. Nice. And then, okay, what else am I seeing? 1.7b number 2. Let me see what that one is. 17b. Oh, is this the, oh yeah, so this is similar, but there's a minus in front. Is that what you were looking at, Linnea?
Yeah.
Okay, yeah. So yeah, it's just a little uglier when there's a minus in front. So let's look at something like a of x, for example, and looking at the range of this. So x plus 3 squared minus 16. So I'm assuming you get the domain. The range, just like the previous problems, we're going to say, okay, 4 minus, we're just going to leave as is. Same with the 2. But the range of the denominator, this is 0 to infinity, but then I'm going to subtract 16. So it's -16, exclude 0, and 0 to infinity. Are we good with that so far? Everyone
Yeah.
okay?
Yeah.
Okay, so now, again, I'm not going to mess with the 4 minus yet. I'm just going to work with this for now. So 2 over -16 is -1/8. 2 over a tiny negative is going to be a huge negative. Union 2 over tiny tiny positive, so it's huge. And then 2 over huge positive close to 0. And here's what I do. Assume this is multiplying by -1. So think of it as -1 times all this, which just means everything flips signs. So, and then we can add 4 at the end. So we're going to have 4 plus, have everything here flip signs. So I'm going to have negative infinity to 0, union 1/8 to infinity, and then add 4 to each piece. So negative infinity to 4, union 33/8 with a bracket to infinity. So that negative in front, think of multiplying every piece by -1, and then you'll add 4. Does that make more sense, Linnea?
Yeah.
Great. I know several of you want me to put up another inverse, so I'm going to do that. And then while people are working on that, I'm going to answer other questions that have been put up, and then we'll go back to the inverse. So I'm going to put up another inverse. So find with a restriction, find the inverse. Put it up here. So I'll call it h of x. Let's vary it up here. Let's do 3 minus the square root 4 minus x squared for x between 0 and 2. So try that, anyone who wants to. And let me go back and see which other people have. 1, 4. Okay, Owen, you wanted to go through 1, 4, 5C?
Yeah.
Okay, let's do that while people are working on this. So if I remember, I have it in front of me so I can write it down. So in that problem, we had f of x is equal to root x, and g of x is square root of x minus 6, right?
Yeah.
And then it said, find this new function, which is f of x divided by g of x. So it looks like this, right?
Yep.
And this is a function because there's every x value won't result in multiple y values. So definitely a function. Now, what do you think about the domain?
I think it's 6 to infinity because yeah.
Yeah, because you've got this would be x greater than or equal to 0, but it has to satisfy both, right? And this would be greater than 6, not even equal to 6, because you can't divide by 0. So the domain would be, right, 6 to infinity. And then another question said, the next one's like, when will this equal 0? And what are your thoughts there?
I said never because for it to equal 0, you have to have 0 on the top, which is not possible.
Yeah, and the reason that's not possible is the 0 is not in the domain, right? The only way a fraction is 0 is if the numerator is 0, which would mean x is 0, but that's not part of our domain. So you're exactly right. So can never be 0. And what about, can it ever be 1?
No.
Yeah, and you can algebraically show this. To do this, you would say, okay, root x equals root x minus 6. And say we tried to, solve by squaring both sides, you get x equals x minus 6. And that's problematic, right? Because the x's cancel out. So that's no, right? So it can't be 1, can't be 0. And then the hard part about this problem is actually finding the range. So one thing we know right away, well, we just showed it can't be 0, right? And we also showed it can't be 1. Could it ever be negative?
No.
No, because you have square roots, right? So it's never going to be negative. So I know it can't be, so y's can't be 0, y can't be 1, y cannot be negative. So the question is, can it be between 0 and 1? And what about greater than 1? What do you think about between 0 and 1?
I don't think that's possible because the top is going to be like greater than the bottom.
Yeah, so this is one that we're not really algebraically going to solve. This was more like a good class thought-provoking one. Yeah, so the denominator, because you're always subtracting 6 from that same value that's in the numerator, it's always going to be top heavy, right? And so the bigger x is, the closer those two numbers will be. They won't be that, like if you put 100 million over 100 million minus 6, I mean, they're not, yeah, they're different, but not extraordinarily so. So the range, it will never be, in other words, the denominator will never be bigger than the numerator. So the range is going to be 1 to infinity. And it'll get super close to 1, as I said. The bigger x gets, the less those two will be different from one another.
Thank you.
And the closer that will be towards 1. That's a little bit more, that's a good class problem. And of course that was the one day I wasn't here. But that's not something that I yet would put on a quiz, something that difficult in terms of the range. but it is a really good problem to think about. Okay, so we're running out of time. So I want to make sure we go over that inverse problem that we just did. How did that go for people?
Pretty well.
Okay.
You good?
Okay, let's see. So let's see how we did. So the steps were to, if we start with x, squared it, multiplied by -1, then we added 4, then we did the square root. I'm getting tiny here. Square root multiplied by -1 and added 3. Okay, so undoing this, subtract 3, divide by -1, so 3. So similar to how the first one that we did together went. Opposite of square rooting is squaring, subtracting 4, divide by -1. Someone shout out if I make a mistake here. Divided by -1. Oh, yeah. So the opposite of squaring is square rooting. And remember, that's the one you have to be like, wait, is it plus or minus the square root? And what is it going to be in this case?
Positive.
Yes, it's going to be positive because notice the domain restriction, which is going to be the range of the inverse, is only 0 or positive. So it's got to be the positive square root of this. So this is my inverse. H inverse of x is that. And wait, did I do all the pieces? -3, the opposite of squaring. Yeah, I did. Okay. We're not done. What's the restriction on this? Because it has something squared. It needs a restriction.
It has to be greater than -1 and less than 3.
Greater than -1. Okay, so let's test how you got that. So you said, so you found the range of h of x, right? So the range of h of x would be 3 minus smallest coming out of that square root is 0. What's the biggest coming out of that square root?
2.
2. And so 3 minus 0 is 3. 3 minus 2 is 1. So it's 4. So I think you said -1 because maybe you took 4 out instead of 2.
Yeah.
Yeah, so just be careful with that. That's common. Yeah, people do that all the time. Common mistake of just forgetting to take the square root. So just be careful with that. Yeah, so but right idea. So square root of 4 being 2, so then it makes it 1 to 3. Okay?
Wait, so in an inverse function, the restriction just means the domain?
So the restriction of, you mean the restriction of the inverse?
Yes.
So the restriction of the inverse function is it's a domain restriction, but it has to correspond to the range of the original.
Okay.
Because remember, domain and range totally flip. So in order to figure out what that restriction on that inverse is, I'm going to go to the range of the original.
All right.
Yeah, domain and range. Yeah, this is the hardest things with, I feel like, with inverses. Domain and range have to totally flip. So in terms of the quiz, I like to do this particularly for the first few quizzes. It's not designed to be a whole period quiz. It's designed to be about 30 minutes. 30, maybe 35. So not that long, but I like to give as much time as possible within the class time. So people won't feel rushed for the quiz. But I do have an assignment for you too. So keep that in mind as well. So if you take the whole time for the quiz, you'll just have to do the assignment at home. It's not a huge assignment. And I would say there's just a mix of, I would say half of it of the quiz is domain and range. It's usually my quizzes are around 50 points, whereas tests are always 100 points. Quizzes can vary. This one's 50 points, but it's about half domain and range, then a quarter inverse, a quarter composition, I would say. That's how it is kind of divided out. So again, time shouldn't be an issue for this. At least I hope not. No, it shouldn't be. I've given similar quizzes in the past. Time is not an issue for this first quiz. Okay, everybody. I hope this was helpful. And I'll see some of you tomorrow and some of you on Tuesday.
Thank you so much.
Bye, guys.
Thank you.
Thank
Thank
you.
you.
Bye.
Thank you.
Thank you.
Thank you.
Bye.
Thank you.